Is that it? Are we on? Okay. Here we are. We're using an iPad this time instead of the Samsung autofocus. How am I doing? Is it autofocusing?
No, but it can only see half of your face. So
What half? Up?
no,
No,
the
side.
left side, the side. Yeah, okay.
Is that good? Am I on?
Yeah, you're
All right, am I on? All right, so not here?
No.
Here.
Yeah.
Okay. We're on. Okay, is that good? Can you see me? Ma. Okay. Sound check. Nah. Okay. We're going to do a problem that may actually be done differently here now than in the book. But I'm going to do it very slowly, and if you utilize the exact same techniques and you follow the exact same rules, you can never get the problem incorrect. The answer incorrect. Understood? So let's say we have three pieces of data. What time do we have until?
We have like, it's 45, so it ends at 15.
So 11:15 we have until? Okay, so we have half an hour, we have plenty of time. So it's going to be 19, 20, and 22? Is that correct?
Yes.
Okay. So that's how it's written. 19, 20, and 22. So it could be meters, centimeters, whatever. There are three measurements. Okay? Now, the question is, what's the average? What's the average of these three measurements? If you add them up and divide by 3, how do you do the average? Clear? You get it? Okay, now, before we do something, let's look and see. On the left, I'm going to put the accuracy in terms of the number of significant figures. Is that okay? Can I do that? I'll use black for that. Okay? This is going to be 2. This will be 1. This will be 2. Correct? Yes? Now, underneath that, I'll put in red. We'll put, on the other side, we'll put the precision, the uncertainty for each. Okay? Okay? So this is going to be plus or minus 1s, correct? Because it's in other words, the smallest place value that actually has a significant figure. That's the uncertainty. Let me repeat that. I said that very quickly, and you didn't really acknowledge that you understood as well as I expect you to understand. Are you ready? If you take a measurement with an instrument, it's easy to determine the uncertainty, the uncertainty, because you simply look at the smallest graduation and then it's 1 less than that. So if the smallest graduation was 10's place, then the uncertainty would be 1's place, correct?
Yes, sir.
Okay, now, so I said to you, well, if you don't have an instrument, how do you determine what the precision is given just the number? Well, it's this. The smallest decimal place that actually has a significant figure in it is the uncertainty. So here is plus or minus 1's place. How do I represent 1's? With the number 1. How do I represent 10's? With the number 10. How do I represent tenths? With the number 0.1. Hundredths? With the number 0.01, etc. Clear? With me? Okay. So what is the uncertainty of 20 written like that? Plus or minus 10. And this is plus or minus 1. Correct? Yes? Now, we're going to add this, correct? We're going to add this. When you add or subtract, what's the rule? When you add or subtract measurements, your answer must have, not can have, not maybe have, not if it's Tuesday you can have this, or if you're in Uzbekistan you can have that. Every answer, every sum of a measurement must have the same exact uncertainty as the measurement with the worst uncertainty? Which one has A, B, or C? Which piece of data has the worst uncertainty?
B.
B, right? So what is the uncertainty of data point B?
10. Plus or
Tens, plus or minus 10, right? So what must my answer have for uncertainty? Tens place, correct?
Yeah.
So mathematically we know that that's 61, correct?
Yeah.
You don't even need a calculator. But scientifically, what's the answer?
60.
60. Now notice this. Because I followed the rules for uncertainty in the addition of data points, it automatically gave me one significant figure. Now, if I'm going to take an average, listen carefully. When multiplying or dividing, the answer must have the same accuracy as the measurement with the lowest accuracy, correct? Yes? You understand that? Okay, now, when making a conversion, the final accuracy must equal the initial accuracy. Because a conversion is not multiplying two measurements together, it's converting one measurement into an equivalent measurement, correct? Now, when you find an average, that's the same thing as a conversion. Clear? So, if I'm going to divide this by 3, I have one significant figure in the number 60. So therefore, I have to have one significant figure in the answer. So what's the answer? 20. One significant figure. Now, let's pretend that this was written like that. Therefore, what's that uncertainty? Plus or minus 1, right? Because you have a written in decimal place. And the rule says that if you have a significant figure bound by, a 0 bound by an actual written in decimal place, and a non-significant and a non-zero number, then that 0 is significant. So therefore, this answer here is actually what?
61.
61. 3 divided by 61,
20.3.
20.3, correct?
Yes.
Which rounds to 20 written like that. You see that?
Yeah.
You can't say that because that has 3 significant figures, so I have to round it to two significant figures. You see that? How that changed? Excellent problem. You guys are a great audience. I'm here all week. See you later. Am I on?
Yeah.
We're trying to get used to the iPad. It's a little different, okay? So if I seem a little bit weird, that's why. Goodbye.
So you were off the screen like a few times.
Not completely, just like a